Hello and welcome to section 10.8, systems of nonlinear equations. Now that sounds like kind of a mouthful, maybe it is, but the idea behind this is not really much different than what we've done elsewhere in this chapter, which is to see where two lines cross each other. The reason this is called nonlinear systems of equations is because we're not always going to deal with a line. Now that first equation you might recognize as a line, so let's take a look at that one. There's our line. I hope that you recognize the presence of a squared term as indicating that, okay, we're going to have a parabola. And in fact, we do. So where these two lines cross each other, or these two nonlinear curves, I guess there's only one nonlinear curve, where they cross each other is your solution. That's what we're going to be looking for. Now, this is pretty easy if you have decimals available, but you might not have decimals available on an exam. Make sure you check with me before you count on that. In any case, let's see how you would actually solve this if you didn't have this wonderful tool here available to you. And that's where we're going to actually get down and do some work. So let's come back over here. One way to do this is by substitution. So let's see. If we solve for y, we can do that by moving the x to the other side. And now that we've got this nice little expression for x, or excuse me, for y, we can substitute that into that expression up there, that other equation. So what's that going to look like? It's going to be 2 times something minus x squared equals 0. Let's put in the 4 minus x. Yeah, I'll put that in a little red here, 4 minus x, just to make it clear that I'm putting in something new. If I distribute that, I get 8 minus x squared equals 0. Now that looks a little awkward and a little less than fun. Actually, you know what? This should be a 2x there. So in order to make that x squared positive, how about if I move it to the right-hand side, and then I move that to the right-hand side, and then move that to the right-hand side. Now, when that happens, things change. We change the sign, so we're going to get x squared plus 2x minus 8 equals 0. This is something that you don't need the quadratic formula for. Hopefully you factor this out. X plus 4, x minus 2 equals 0. Two numbers that multiply to negative 8 and add to 2. Now the question is, well, where's the solution? That's pretty easy. You have this times this equals 0. So either x plus 4 must equal 0 or x minus 2 equals 0. Now, I fully expect that most of you will probably just take the shortcut and say, oh, well, I'll just change the sign on this. Now, those are the x coordinates. Please keep in mind your solution is going to have an x and y coordinate. So let's see if we can't figure out the x and y coordinates when, say, x equals negative 4. So when x equals negative 4, let's put that in here. Y equals 4 minus negative 4. I'll put it in this way. Negative 4. Y minus double negative 4 is going to be y plus 4, or y equals 8. So overall, our solution here should be negative 4 for x and 8 for y. How about the other one? Well, let's do that one as well. So again, I'm going to try and find a solution of the form x and y. This time I'm going to plug in a 2. So when we plug in a 2, well, that's pretty straightforward. 4 minus 2 is 2. So I end up with 2 for x and 2 for y. Let's double check that. That's pretty easy when you've got a graphing calculator or Desmos. So let's just click on these 2 points. Now you can do that with a graphing calculator as well. It's just a little bit more tedious to do that, but you can double check your work on a graphing calculator. You don't even have to make sure that it's the exact right point. You can kind of eyeball it and say, all right, well, that looks pretty close. So let's fire up the graphing calculator. I'm doing it with this one because I can actually graph this. It's not too bad. You do have to rearrange this so that you have y solved for. So let's look back here for a second. If you were to solve for y in that first equation, You have 2y minus x squared equals 0, or 2y equals x squared, or y equals 1/2 x squared. So there we go. I'll plug both equations in there. I need to get y solved for in both. So here we go with one of our equations. Here's the other one. Let's see what they look like. Come up here, clear out the other stuff. Make sure your plots are turned off. Now for convenience, I'm just going to put in 0.5 x squared. And then the next equation is going to be 4 minus x. For the window, well, I know I don't need anything below the x-axis, so I'm not going to go below the x-axis. On the y-axis, let's go from, say, 0 to 10, a scale of 2. On the x-axis, -6 to 6 might be wider than I need, but that's okay. Let's look at our two graphs. And you can kind of eyeball the solutions here, right? So at a height of 2, 4, 6, 8, and at an x-coordinate of -4, we've got a solution there, and we've got a solution there. You can also double check those if you wanted to really be exact by hitting the second key, then the calc key, and going through the intersect. Let me just do that for you real quick. Go down to 5, intersect, saying, all right, well, where do you want to look for point of intersection from the first curve? So just get close to that point of intersection, and you're going to press enter a total of 3 times once you get close to that point of intersection. 1, 2, and 3. There you go. Occasionally, it'll be off by the minutest of amounts, but generally speaking, it should be pretty close. Well, let's keep going. Let's try some more here. So the next example, we're going to deal with a couple parabolas. So let's see what's going on with that. So example B, x squared minus y equals 7, and 2x squared plus 3y equals 24. Now the last problem we solved by substitution. Let me show you that there's a variety of ways that you can do this. One of our goals in working with these nonlinear systems equations when we're solving them is to get rid of one of the variables. So in this case, I can get rid of, let's see, I can get rid of the x squared terms by multiplying this top equation by -2 and adding it to the bottom equation, or I can get rid of the y term by multiplying this equation by 3 and adding it to the second equation. Let me do that by getting rid of the y's here. So I'm going to multiply this equation by 3. That'll give me 3x squared minus 3y equals 21. And I'll add that to the equation down below. And so that looks pretty good. Let's see. When we do this, these are going to cancel each other out. So that's nice. And I'll end up with 5x squared equals 45. Well, I want to solve for x, so I can divide both sides by 5 and get x squared equals 9. I hope that if you're sitting there thinking x equals 3, that you remember there's a little bit more going on than just a 3. Yeah, there you go, plus or minus 3. So there's two possibilities here. X could be 3 or x could be -3. And let's see how that plays out. So if we actually look at the graph here, and let me shut this one down and go to this graph on Desmos. Both of these are going to be parabolas. So let's turn each of them on. And from the shape of these parabolas and their graphs, you can see it looks like there's 2 points of intersection here and here. One of them at -3, one of them at +3. Let's go through and find both of those solutions in terms of x and y coordinates. You want to make sure you give me both coordinates. Well, I'm happy if you only give me the x. So when x equals 3, Let's put that into the first equation. That's going to be 3 squared minus y equals 7, or 9 minus y equals 7. If I subtract 9 from both sides, I get negative y equals negative 2, or y equals 2. That doesn't really change much if I put in x equal negative 3. Negative 3 squared is the same thing as positive 3 squared. I get 9. And once again, I'll end up with y equals 2. So as before, there's 2 points where these graphs overlap. One of them is at 3 and 2. The other one is at negative 3 and 2. Now, regardless of whether or not I use Desmos or let you use Desmos, you should be able to show me the work here. Now, if I do let you use Desmos, hey, that's great. That means you can check your answer. Let's do that right there and right there. There's your 2 solutions. Pretty nice. Pretty nice. All right, comments or questions? Let's keep going then. Let's move on down to the next one. So example C here. Again, we're stuck with a couple of parabolas, but here's where I can ask you a question. You can check it on Desmos, but unless you've actually solved it, you're not going to get full credit. You're not going to get the right solution. You might get a decimal approximation, but not the right solution. So a couple more parabolas. We will change things up a little bit. Looks like there's 2 points of intersection, but they're not really nice points, are they? So let's copy those equations down and work through example C. So we got 3x squared plus 4y equals 23, and 2x squared plus 5y equals 6. All right. Well, let's start by figuring out how we're going to approach this one. You've got a couple choices. You know, you could solve for either of the variables, do it. That's fine. Do it by substitution. Since nothing looks easy to get by itself, that is, I don't have something that has a coefficient of 1 or negative 1, and I can't necessarily easily get something to cancel out, I'll just use the addition method. So that would be trying to get one of these variables to cancel each other out. I need to have the same coefficient here and here, but opposite signs. So for instance, I can multiply the top equation by negative 5 and the bottom equation by 4. That would give me minus 20y here and a positive 20y here. And when you add those, they would cancel. But you know what? It might be nicer to get the x squareds to cancel because I don't have to multiply by as big of a number. So for instance, up here, I can multiply this equation by negative 2. So that's going to give me negative 6x squared minus 8y equals negative 46. And then I'll multiply this one down here. Well, I need to get a positive 6x squared here. So I'll multiply this one by positive 3. And that's going to give me 6x squared plus 15y equals 18. All right, well, let's add these together. And obligingly, those cancel each other out. That's great. That's what we wanted to happen. So that's going to give me 7y equals negative 28. Well, that's pretty special. That just means y equals negative 4. Perfect. So y is negative 4. That's part of our solution. We need to figure out the other part of it. And here's where I got to give you a heads up. It's not going to work out even. That's okay. So let's work through this. If we let y equal negative 4, I'm just going to do it in the first equation. You can do it in the second equation. they're going to work out about the same. Maybe the second equation would be easier. Well, let me stick with the first equation, 3x squared plus 4 times negative 4 equals 23. So let's put that negative 4 in here. So that's 3x squared minus 16 equals 23, or 3x squared equals 39. If I divide both sides by 3, I get x squared equals 13. So x is going to be square root of 13. But did you remember the plus or minus? I hope so. Remember that plus or minus. So when y equals negative 4, so negative 4 for y, you get a square root of 13 for x, and negative square root of 13 for x. Bam. Now, if you, yeah, that's it. There's our two solutions. So x and y, and looking good. If you check back with the graph, your graph can kind of verify it. When you check for these points, you see, oh, you get 3.60555, et cetera, and negative 3.60555. And then you can compare that to what the actual value of the square root of 13 is. But my guess is that most of us can't look at this and say, oh, yeah, I know what it is. It's square root of 13. Even if you can, I still need to see the work, right? So if I'm nice enough to use Desmos, make sure you can show me the work. Let's move on down to example D. Now, example D is going to change things up a little bit because we no longer have just a parabola or two. So this first one's a parabola, all right? And you might notice that it's a parabola that faces sideways. That's because we have a y squared term and not an x squared term. Below that, we have two squared terms, a y squared term and an x squared term. And that's going to make this an ellipse. So, bam. Uh-oh. Take a look at this one. Try and predict, while I copy down these equations, try and predict how many solutions you expect here. When you give me the x and y coordinates for all the solutions, how many solutions are you going to give me? Would you say 4? I hope so, because there's 1, 2, 3, and 4. 4 solutions. And none of them look particularly easy or, familiar. So let's take a look at how we're going to solve this one. This one seems like it's handed to us on a silver platter. You could solve for y squared from one equation, put in the other equation. Why not just do this? This is tailor-made for the addition method. If you add these straight down, I get 0. Over here, I get a -1. These terms cancel each other out perfectly. But be careful with those. Those don't cancel each other out. In fact, you can't add these together because they're not like terms. So it's just 2x squared plus x minus 1. Now, when I was a student in this class, I was terrible at factoring these things. I hated it. When there was a leading coefficient of 1, something other than 1, oh, I panicked. Now, you can factor this if you like. You can use the quadratic formula if you like. Generally speaking, I'm not going to be mean enough to make you use the quadratic formula on something like this. So we'll factor. Let's see if we can't bluff our way through this. I know that the first two terms have to multiply together to give me a 2x squared. There's not too much that multiplies together to 2 and 1. The last terms have to multiply together and give me a -1. So it's going to be a 1 and a 1, except one of those is going to be positive and one of them is going to be negative. So is it minus here and plus here, or is it plus here and minus here? Well, if you actually checked it by foiling it out, you'd see that I want a +1 here, and then the -1 here. That gives me a nice factored form of this. Hopefully you can read off the solution here. That's going to be x equal -1. And here, well, if you keep in mind what we did with the other problem, you might realize that we've got this times this equals 0. This equals 0 when x equals -1. Let's find out when 2x minus 1 equals 0. That's going to be when 2x equals 1 or x equals 1/2. So you've got two solutions for that one. Let's see if we can't finish this off. Now, overall, remember, we expect 4 solutions. So let's go back and plug those values in for x and see what we get for y. So let me give myself a little bit of room up here. So like this. And let's see here. Let's start by setting x equal to 1/2. And I'm going to put that in this first equation right there. That's going to be 1/2 minus y squared plus 4 equals 0. 4 plus 1/2 is 4.5. So I'm going to leave the 4.5 on the left-hand side. The y squared, I'm going to move that to the right-hand side. Can you tell me why? Why would I move that to the right-hand side? What's the benefit? If you said because that's going to make that negative a positive, and then you don't have to deal with a negative, give yourself a couple bonus points. Well done. So 4.5 on the left-hand side, I'm going to rewrite that. Instead of 4.5, I'm going to write that as 9/2 equals y squared. And then we can take the square root on both sides. Hopefully you've seen this a couple times. You realize that the square root of 9/2 is going to have a plus or minus out in front of it. I can take the square root of the numerator, so it's plus or minus 3 over the square root of 2 equals y. So 2 of my solutions are right there. I've got when x equals 1/2, one of these two. Let's put in, well, I'll save our solutions till the end, write them all together. The next one should be a little bit easier. We're going to set x equal to 1. So that's going to be plugging that in here. 1 minus y squared plus 4 equals 0. I'll play the same game as I did last time. I'll move the y squared to the right-hand side. And 1, oh, it's -1, my bad. -1 and 4 give me 3, so I'll end up with 3 equals y squared, or plus or minus the square root of 3 equals y. So I had 2 different values for x, and each value for x gave me 2 values for y. Overall, my solution is going to look like this. When x equals 1/2, y could equal 3 over the square root of 2. Or when x equals 1/2, y could equal -3 over the square root of 2. When x equals, that should be a -1. When x is -1, y could be the square root of 3. Or when x equals -1, y could equal negative the square root of 3. So 4 solutions all right here. There's your 4 solutions. You can double check with Desmos or your graphing calculator that they intersect at the right spot. This would be a tough one to put in your graphing calculator because you'd have to solve for y, and that's kind of tedious. I did note for you that 3 over the square root of 2 is about 2.121. So there you go. There's your 1/2 and positive root 3 over 2 and 1/2 and negative root 3 over 2. Likewise, we have -1 and negative square root of 3, -1 and positive square root of 3. So looking good. All right, rolling along. How you guys doing? Hanging tough? Your head spinning yet? Please feel free to reach out with some questions. Hit me up on a Zoom or catch my office hours. Look at other YouTube channels. Khan Academy's got some pretty good stuff. Even Chat GPT can solve some of these problems. Not that I recommend that you necessarily go there, but they can. In fact, it's kind of funny, just out of giggles, I asked it to solve our first problem without using, let's see, did I? Let's see. Other than using substitution. And it did it with substitution. So whatever. But there's our first problem. I think the way we solved it was a little bit more elegant, but there it is. Let's get back and work with some more problems. So move down to example E. And let's shut these off. We're down to example E. 2x squared plus y. And an interesting one. Now we got a cubic equation. So there's something I want you to be aware of when you're looking at this one. So you've got a parabola that faces down. That's great. And then a cubic equation. How many solutions are you seeing here? I'll give you a moment to think about that while I copy down the next set of equations here. For example, E. How many solutions do you expect here? So if you said 2, I certainly understand that. We see 2 solutions right here, but you have to be a little bit more careful. These lines look like they might cross each other. So if you hit the shift key and put your cursor on the vertical axis and scroll in a little bit, you can kind of zoom in or zoom out in the Y direction. You can do likewise with the X direction, the horizontal axis. Press the shift key, put your cursor on the horizontal axis, and then scroll, and then you can kind of zoom in a nice tailored fashion. But I see 1, 2, 3 points of intersection. Wow. Okay. Let's see how we can find those. In this particular problem, well, I can't really get something to cancel out other than maybe the Y. Now, for variety's sake, instead of just adding these equations together and getting things to cancel that way, I'm actually going to solve for Y. Y equals negative 2x squared. I'm going to do this one by substitution. I'm going to take that expression and plug it in here for Y. So what's that going to look like? Well, that's going to look like x cubed minus 3x minus negative 2x squared. And do be careful that you have that double negative in there. Let me put it in this way, minus 2x squared. That double negative becomes a positive, and I'll rewrite it like this, x cubed plus 2x squared minus 3x equals 0. Before you start trotting out some of your fancy theorems from chapter 3, let's look at this a different way. Can we factor this? Do you see anything that factors? I know it's a cubic equation, but probably the easiest thing to overlook in factoring is the GCF, greatest common factor. And there's an x that I can factor out of all of this. That leaves behind x squared plus 2x minus 3. And we can continue to factor it from here. That x stays out in front. That's going to leave behind, well, it'd be an x plus 3 and x minus 1. See if you can read off the solutions here for x. Well, kind of like before, you're multiplying several things together and get 0. This is 0 when x is 0. This is 0 when x is -3. This is 0 when x is 1. So there's your three solutions. We do need some y coordinates here. You can get the y coordinates by plugging the values for x in here. So our solutions would be 0 and 0. That's 1. If I plug in a 1, 1 for x gives me -2 for y. And the second one, for the last one here, we got to be a little bit careful. So let me actually show that out here. When x is -3, let's see what happens with our y value. So y equals -2x squared. Y equals -2 times -3 squared. Notice that I'm plugging this in with parentheses. So when you square that, you get a +9 times a -2 gives you a -18. So -18. There you go. Once again, you can corroborate this by looking at the appropriate decimals graph. 1, 2, and 3. Those are our solutions. So I hope you're starting to get the hang of things here. Maybe you want to do yourself a favor, pause the video, and try and work through a problem or two here. So I'll show you the next two examples, F and G. Maybe try these for yourself, especially G's got a little bit of a twist in it. See what you come up with. Or if you just want to sit back and enjoy the show, then we can do that as well. Let me move on with example F. Now, example F, hopefully you start getting used to some of these things. We'll spend some more time on it later. But this is going to be a graph of a circle. So let me shut these off. You sure you don't want to try this yourself? All right, fine. I'll do it. So this is going to be the graph of a circle. Now, it doesn't much look like a circle. That's okay for the moment. And this is going to be a parabola. Notice it's a parabola in y squared, so that means it's going to open sideways. Now, if it doesn't look like the circle that we expected, you can go up here to the tool icon and hit zoom square. This will square things up so that circles actually look like circles. So, kind of like before on several of these, try and figure out how many solutions do you expect here? How many solutions are we going to get overall? All right. I'm hoping that you said 3, because we got 1, 2, 3 points of intersection. Again, a couple of these are kind of on the ugly side, so we're going to need to solve them and then check our solutions. You could do it by the addition method or substitution. This one seems like it's screaming out for substitution, just kind of like the last one. You got x equal y squared. So I can just plug that in here. That y squared gets replaced by an x. So if I make that substitution, I get x squared plus x equals 4x. I'll move this to the other side. And if I subtract 4x, x minus 4x gives me minus 3x. Okay, looking great. Just like example E, I can factor out a GCF, x times x minus 3 equals 0, gives me either x equals 0 or x equals 3. So those are your two x coordinates. For your x coordinates, you need to find the associated y coordinates. Let's do that up here. I'm going to start by setting x equal to 3. So it's going to be 3 equals y squared. Doing that in here. So plus or minus square root of 3 equals y. And maybe you're getting used to the decimal value of square root of 3, about 1.732. What if I set x equals 0? Well, then I get 0 equals y squared. There's no plus and minus 0. is just 0. So you're only getting one solution here, whereas here we got two solutions. Overall, your solutions look like this. When x was equal to 0, let me do that here. When x was equal to 0, I got y equal to 0. When x is equal to 3, I got two different solutions. I got square root of 3 and negative square root of 3. Three solutions. And once again, all three of these solutions are going to match what you see on Desmos. You can get this out of your graphing calculator. It's just more work. I'm not going to do that one here. All right. Did any of you try example G? Is there any surprises in example G? Well, it's a little different because you got a graph that's going to look like a hyperbola. Not exactly a hyperbola, but close enough. And then this one. Let me zoom out a little bit. There you go. You got a parabola that faces down and this rational equation with a vertical asymptote at 0 here. So how many solutions are there here? How many solutions do you see? Well, I don't see any. I don't see how we're going to solve this. But you might not have this graph available to you very easily on an exam. So if you didn't, or if you just didn't take the time to look at this, the question might be, well, how am I going to know? How am I going to know that there's no solution here? Well, let me copy down the equation here real quick, and then we'll figure it out together. Well, I can't add a multiple of this equation to this equation to get something to cancel out. So the best thing I can do would be to solve for one of the variables and substitute it into the other equation. Now, the first thing that occurs to me is that it's very easy to get y by itself. So if I divide both sides of this by x squared, I can get y equals 9 over x squared. Okay. Let's substitute that into the other equation. So this expression here gets plugged in just for the y. X squared plus 4 times 9 over x squared plus 12 equals 0. Add 9 and the 4 to multiply, I get x squared plus 36 over x squared plus 12 equals 0. And most of you are probably cringing, going, oh, God, fractions now? That's just the worst. But if you don't like fractions, get rid of them. This is an equation. What's the easy way to get rid of fractions in an equation? You can multiply both sides by the lowest common denominator. Now, in this case, that LCD is x squared. This has a denominator of 1. This has a denominator of 1. So I'm going to multiply everything on both sides by x squared. There's a part for you to play in this as well, so pay attention. On the right-hand side, 0 times x squared is still 0. 12 times x squared is 12x squared. Here's your part. What happens when I multiply these two together? What do we get? X squared times 36 over x squared. I'm hoping that you cancel out the x squareds. You're just going to be left with 36 x squared times x squared. Yes, you get x to the 4th, but are you adding or do you multiply? You get the same thing either way, but I hope you realize that when you multiply things with the same base, you add their exponents. That's looking a little bit better. Let me rearrange that as x to the fourth plus 12x squared plus 36 equals 0. Maybe you remember your work in intermediate algebra. Maybe you remember seeing it someplace in college algebra where this is quadratic in form. This exponent is half of this exponent. That allows you to make a little u substitution. One way or another, it's going to allow us to factor this. If I let u equal x squared, and I squared both sides of this, u squared would be x to the fourth. So I get u squared plus 12u plus 36 equals 0. That factors into u plus 6 times u plus 6, which means u equals -6 or u equals -6. Now, this was just kind of a quick crutch here to get around factoring this. Maybe you could look at this and say, oh, well, that's really just x squared plus 6 times x squared plus 6. If you can factor that, that's great. Nothing wrong there. But either way, u is taking the place of x squared, so I get x squared equals -6. Or here, because I'm multiplying these things together, what makes this equal to 0? That's when x squared equals -6. There's a problem here. Do you see it? How do we solve? Kudos to you for remembering the plus or minus, but that's going to give you an imaginary solution. You're not going to see where that intersects on the xy plane because it's really an imaginary solution. We just don't live in a high enough dimension to be able to graph that. So we're stuck. You're not going to see it. Basically, there's no solution. And we knew that from the get-go because we didn't see where these graphs overlap each other. So no solution. Whew. A lot of work to come up empty-handed. Yes, I agree. All right, just a couple more here. Let's shut that one off. Look at example H. So example H, again, you've got a circle, x squared plus y squared. Notice that the coefficients here of the squared terms are the same, and they're both positive. So that's going to be a circle. The radius of that circle is going to be the square root of 23, if you're very interested. Now, here, well, things are pretty close, but because I've got one of these square terms is positive and one of them is negative, this is going to be a hyperbola. So there's going to be two branches of a parabola that face away from each other. How many solutions are we looking at here? Yeah, you got it. 1, 2, 3, 4 solutions. So let's take a look at what that's going to pan out as. And I think we'll go back to solving this with the addition method just for the practice. And because it looks terribly convenient to do this by the addition method. So copy this down for yourself. Well, I copy it down as well. Would have a hard time coming up with something better suited for the addition method. Let's break both of these down. That's going to be 2x squared equals 28. So x squared equals 14. X is plus or minus the square root of 14. Okay. Now let's go through and find the y coordinate. So if I set x equals the square root of 14, that's going to be the square root of 14 squared plus y squared equals 23. So let's put in the square root of 14 here. Let me do it this way. Square root of 14 squared is just going to be 14 plus y squared equals 23. y squared is going to equal 9. What do you think? Y equals 3? Give yourself a pat on the back if you're screaming at the screen and saying, no, 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 you need that plus or minus. Good job. So that gives you two solutions. That gives you square root of 14 and 3, and square root of 14 and -3. Now here's a little trick you can save yourself some time. If I put in a negative square root of 14, remember we're going to check both of these. Set x equal negative square root of 14. When I square the negative square root of 14, I'm just going to get the same thing I got before, right? When you square a negative, you get a positive. 14 plus y squared equals 23. You're going to end up with y equals plus or minus 3 as before. So the short story is I get negative square root of 14 and 3, negative square root of 14 and -3. 4 solutions, just like we predicted. Check it numerically on Desmos, if and where you can. Make sure you got them right. Okay, 2 more. Let's see what's happening with example I, a hyperbola and an ellipse. If you wanted to check, gee, is that really an ellipse, kind of an oval shape, not a circle? We can go back here, and because we don't have a little option to zoom square, that means that it's already squared up. So if you distort it in one way or another, if I stretch it out this way, let's take a quick look back here. Now it says, oh, do you want to square things up? Yes, I do. So there it is. So again, you've got 4 solutions. Let's take kind of a quick look at this bottom one here. I know you're busy. I want you to get out of here as fast as you can. How many solutions on that one? Yeah, just 2. So you can kind of read those off, 4 and -4. This one looks tailor-made for substitution. Let's solve this other one by the addition method again. Why not? That works out pretty good. We expect 4 solutions. So example I. In fact, I invite you to pause the video and try and solve it yourself. See if you can come up with all 4 of these solutions. Personally, I'm going to do the addition method. Although you are going to have to think a little bit in order to get this to work out pretty nice. So last chance to pause the video before I start working on this. Ready, fire, aim. Bam. I can multiply the bottom equation by -5 to get these to drop out, the x squares to drop out. But I think I'd rather multiply the top equation by 2. It's just a smaller number. So let's do that. Multiply the top equation by 2. So 2 times that. That's going to be 10x squared minus 2y squared equals 32. Make sure that you multiply every term here. X squared plus 2y squared equals 12. So I get 11x squared equals 44. I think this is going to work out pretty nice. X squared equals 4. Go ahead. Beat me to it. Plus or minus square root of 4 is plus or minus 2. So there's 2 solutions. Maybe we can kind of take the same shortcut that we had the last time, because squaring the square root of 14 and squaring the square root of -14 gave us the same thing. If we let x equal 2, let's do that in the bottom equation. That's going to be 2 squared plus 2y squared equals 12. So 4 plus 2y squared equals 12. 2y squared equals 8. Y squared equals 4. So y equals plus or minus 2. So you get two solutions from this. That would be x equal 2, y equal 2, x equal negative 2, excuse me, x equal positive 2, and y equal negative 2. So we get both solutions for x equal 2. Let's clean that up just a little bit. There you go. It never happened. If I let x equal negative 2, I'm going to end up with the same thing, plus or minus 2. So when x equals negative 2, we're going to get two solutions. It's either going to be positive 2 or negative 2. All four of those are going to lie on our graph. Still with me? Last one. All right. Mention my dog Aspen on your next test for some extra credit. He's a cool little guy. Surprised I don't hear him chasing the ball upstairs. Let's just double check here. 2 and 2, 2 and negative 2 and 2, negative 2 and negative 2, and 2 and negative 2. So all four of those are our solution. Please don't forget the plus or minuses. That does make a big difference in terms of your score. I'll generally take off 2 points if you forget half of your solutions, as you forget that plus and minus. Finally, a circle of radius square root of 32, and the line y equals negative x. So example J, x squared plus y squared equals 32, and x plus y equals 0. So we're going to go back to substitution on this one. I think it's easy enough just to solve for y equals negative x. And then I'll plug that in for y. So let's see what happens there. I get x squared plus negative x squared equals 32. Now, when you square negative x or you square positive x, you get the same thing. Now, please don't add this together and get x to the 4th. Let's be a little bit careful and understand what we've got and why we're going to get what we're going to get. I've got one of them here and one of them here. When you add 1 plus 1, you get 2 of those like terms. So 2x squared equals 32. Divide both sides by 2. X squared equals 16. X equals plus or minus 4. You can do the square root part, right? So when x equals 4, I get y equals negative of 4. So I get y equals negative 4. 4 and negative 4. When x is negative 4, again, I'll substitute in here. Y equals negative of negative 4. Y equals positive 4. So negative 4 and positive 4. And that's it. Those are my two solutions. When you look at it on the graph, they match perfectly. Awesome. Make sure you talk to me about whether or not we're going to be using Desmos on the exams. Either way, if you use Desmos or don't use Desmos, I still expect to see work that justifies this. If I'm kind enough to let you use Desmos, you can double check yourself. Great. Please do it. I want you to get these things right. For now, that's it. I hope that you picked up a lot here. Go back, rewatch this, slow it down a little bit. I know I was talking a little bit fast maybe, but I don't have anyone here to slow me down with questions. So ask me some questions in person, and we'll see you soon.